Welcome to the mathematics class of Mr. Larry Whittington. Stay tuned as Mr. Whit get on here today and speak to us about fractions. I hope you figure to understand what he gonna teach. Get your ink pen and your pencil out, your calculator, and get ready to learn something from Mr. Whittington, Fort Bend Tutoring.
Ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, FBT, and today's lesson is about complex fractions. That's right, what to do when you have a fraction within a fraction. Keep in mind, ladies and gentlemen, that any fraction is a division problem, and with that in mind, we'll be solving problem number 1. In problem number 1, we have 2/3 divided by 4/5. So to solve this problem, all you have to do is rewrite this problem as a division problem. So you'll have 2/3 divided by 4/5. Remember that when you're dividing fractions, you always multiply by the reciprocal of the second fraction. So I'll rewrite this as 2/3 times 5/4. I have a preference of simplifying before I multiply, so I'm looking for a number in the numerator of either of these fractions that has something in common with any of the denominators in either fraction. And I found that 2 and 4 can both be reduced by 2. So 2 will go into itself once, 2 goes into 4 twice, and then we multiply straight across. So 1 times 5 gives me 5, and 3 times 2 is 6, and that's my answer, ladies and gentlemen. All right, so notice how we took our original problem and rewrote it into more familiar form. Once we had our problem rewritten as 2 fractions dividing, we knew how to handle the problem and go forward from there. So that's what we'll be doing, ladies and gentlemen. We'll be rewriting these problems into a more convenient form in order to get the solution. So that was problem number 1. Let's check out problem number 2. In problem number 2, notice that we have 2 fractions in the numerator subtracting divided by 2 fractions in the denominator adding. So I'm going to show you a different technique in order to solve this problem. Alright, so anytime you have multiple terms in the numerator and multiple terms in the denominator, we can simplify the problem by multiplying by the common denominator of all of the fractions. So notice that my denominators are 9, 3, and 6. So the common denominator for all 3 of those values would be 18. 18 is the first number that 9, 3, and 6 would go into evenly. So here we'll be multiplying the numerator and the denominator by 18, that lowest common denominator for all of the values that we had in the problem. And by multiplying by this form of 1, we're not changing the value of the original problem, just the way it looks. So what I'll do next is I'll distribute the 18 to every term in the problem here, okay? So I got my arrows popping. Next, 9 goes into 18 twice, and 2 times 5 is 10. So I'll end up with 10. So multiplying 5/9 times 18 gives you a result of 10. Minus 3 goes into 18 6 times, and 6 times 1 is 6. All right, so that's my new numerator. In the denominator, I have 3 going into 18 6 times. 6 times 2 is 12, plus 6 goes into 18 3 times, and 3 times 1 gives me 3. From here, the 10 minus 6 is a value of 4, and 12 plus 3 gives me 15. From here, ladies and gentlemen, that's it. We can't simplify any further, so this is going to be my answer here. So since we had multiple terms in our original problem, we used the technique of multiplying every single element of our complex fraction by the common denominator of 18. That allowed us to simplify the original expression so we no longer had fractions within the fraction. From there, we simply subtracted and added to get our result, and of course you need to always make sure your fractions are in the most simplified form they can be in. Alright, that was problem number 2. Let's check out our next example here. Problem number 3. In problem number 3, ladies and gentlemen, I want you to recognize that we have a fraction divided by a fraction. So the technique of the first problem will be implemented. All you have to do is rewrite this as a division problem. So that's what we'll do. I'm going to have this rewritten as 3x cubed y squared all over 8 divided by 9x to the 4th power y cubed divided by 16. Once I have it in this form, I'm going to then multiply by the reciprocal or the flip of the second fraction. So rewriting this, I have 3x cubed y squared over 8 times 16 over 9x to the 4th power y cubed. From here, I'm going to simplify before I multiply. I know that 8 goes into itself once, it goes into 16 twice. 3 goes into itself once, it goes into 9 3 times. And what I'll do for now is I'll put a pause on simplifying because I like to combine all my variables first before I reduce them. So let me show you what I'm talking about here. Multiplying straight across the way it is, I'll have 2x cubed y squared over 3x to the fourth power y cubed. Once I have it in this form, I know that my variables will remain wherever the largest exponent is. So I'll start out by having 2 and 3 in the denominator, and when I look at my x's, my variable x, I have x to the third power in the numerator, x to the fourth power in the denominator. That tells me that x will remain in the denominator because that's my largest exponent on x. When I look at my y variables, I have y squared over y cubed. So therefore my y variable will remain in the denominator, and to find out its exponent, you simply subtract. So 3 minus 2 leaves me with an exponent of 1 on my variable of y. So remember, your variable remains wherever the largest exponent is, and you simply take the difference of the exponents to find out what your remaining exponent will be. So 4 minus 3 gave me x to the first power, and 3 minus 2 gave me y to the first power, and this is my answer here. That's it. I'm going to red box it. There it is. All right, ladies and gentlemen, that's problem number 3. Let's continue on. Problem number 4, we have the following problem. We have 4 minus 1 over p divided by 9 plus 5 over p. So I have multiple terms within this complex fraction. I need to multiply by the common denominator of all the terms. And in this case, it's just going to be the variable p. So multiplying the numerator and the denominator by p, I'll be distributing here. Okay, and what happens is 4 times p is 4p minus, here multiplying 1 over p times p, the p's will cancel out to leave me with 1, and then in the denominator 9 times p is 9p plus the p's here will cancel out to leave me with 5. So each and every term, ladies and gentlemen, was multiplied by p, and when you simplify that, you would end up with 4p minus 1 over 9p plus 5, which is our answer. That's it. That's problem number 4, ladies and gentlemen. Done and done. All right, let's continue. We have our next problem. Problem number 5. Here we have x squared minus 1 over x divided by x plus 1 over 3x cubed. Notice how once again we have one fraction divided by another fraction. Anytime you have this format, you can simply rewrite the problem as a division problem between fractions. So I have it rewritten as x squared minus 1 over x divided by x plus 1 over 3x cubed. The next thing I'll do is I'm going to factor my numerator as well as rewrite this problem as a multiplication problem by multiplying by the reciprocal, the flip of the second fraction. So factoring out this difference of 2 squares in the numerator, I'll have x plus 1 times x minus 1 all over x times 3x cubed all over x plus 1. From here, I'll look to simplify before I multiply. I know that this x plus 1 here will go into itself once, and it'll also go into itself once here in the denominator. In other words, I can cancel those like factors away. Now, this x will go into itself once, and that means that this will become x squared in the numerator there. So I've taken away an x from this x in the denominator as well as an x away from that x cubed to leave me with x squared in the numerator of the second fraction. From here, ladies and gentlemen, I'll be multiplying straight across. So I'll be ending up with 3x squared times x minus 1, and that's my answer. That's it, ladies and gentlemen. In the denominator, it would have been simply 1 times 1, which is 1, and that doesn't change a thing. So we leave our answer as 3x squared times x minus 1, and that's the result of problem number 5. All right, next problem. Here in problem number 6, I have 4x squared minus 9y squared over xy divided by 2 over x minus 3 over y. So notice I have more than just a fraction divided by a fraction here. So this is when I'll use the technique of multiplying by the common denominator of all 3 denominators here in this problem. So the common denominator of all 3 elements is going to be xy. So I'll be multiplying the numerator by xy as well as the denominator by xy. So when we multiply our numerator by xy, what happens is this xy will cancel out with that one. So that'll give us 4x squared minus 9y squared all over, and the denominator 2 over x times xy, the x's will cancel out to leave me with 2y, minus here the y's will cancel out, and that leaves me with 3x. Okay? So at this point, we no longer have any complex fractions. We just have 4x squared minus 9y squared over 2y minus 3x. What you can check out from this point, ladies and gentlemen, is to see if you can simplify any further. So we know that the numerator is a difference of two squares, so you end up with 2x plus 3y times 2x minus 3y. All of this would be over 2y minus 3x. So, checking out my results here, there's no way that we can cancel out anything, so that means that our original response was correct. It's in its most simplified form here as 4x squared minus 9y squared over 2y minus 3x. Even if you were to factor out a negative in the denominator, you still wouldn't be able to cancel out either of these factors in the numerator. So that's why it's okay just to leave it as 4x squared minus 9y squared over 2y minus 3x. All right, let's check out our next example here. In problem number 7, we have y minus 3 over 3 all over 4/9 plus 2 over 3y. Notice this problem has many different parts to it, correct? So we'll be multiplying by the common denominator of all of the elements here, all the fractions within the fraction. So I'm looking at denominators of 3, 9, and 3y. So that common denominator for those three denominators, so the common denominator for all is going to be 9y, and that's what I'll multiply the numerator and the denominator by, 9y. So distributing this, I'll have 9y times y, which gives me 9y squared. I'll have a negative. 3 goes into 9 3 times, so I end up with 3y times the quantity of the numerator, which is y minus 3. All right. Then in the denominator here, I'll have the 9's canceling out. That leaves me with 4y plus 3 goes into 9 3 times, so I have 3 times 2, which is 6, and my y's will cancel out. So this is what I have thus far. And what I can do from here is distribute this negative 3y into this set of parentheses here. So notice I have my arrows popping here. All right, using distributive property. So bringing down this 9y squared, now multiplying negative 3y times y, I have negative 3y squared. Multiplying negative 3y times negative 3 gives me a positive 9y, and all of this is going to be over 4y plus 6. Once we've done that, we're going to look to combine like terms. So I'm going to subtract 9y squared minus 3y squared to get 6y squared plus my 9y all over 4y plus 6. Once I have this, notice that in the numerator and in the denominator we can factor. Let's go ahead and do that because we may have an opportunity to simplify this even further. So factoring out 3y out of the numerator, I have 3y times 2y plus 3. And then in the denominator, I can factor out 2. So factoring out 2, I'm left with 2y plus 3 inside the parentheses as well. Notice that these factors are identical, which means that I can cancel them out. So 2y plus 3 goes into itself once, and 2y plus 3 goes into itself once to leave us with a result that is 3y all over 2. And that is our answer, ladies and gentlemen. That's it for problem number 7. 3y over 2. Let's look at the next problem. Problem number 8 is coming up. We have problem number 8. Notice here we have y plus 3 over y minus 4 over y minus 1 divided by y over y minus 1 plus 1 over y. Here is another example of where I would want to use a technique of getting the common denominator of all of the denominators here. So I'll be multiplying each and every term by y times y minus 1. Alright, and that goes to the numerator and in the denominator, multiplying that lowest common denominator to each and every element within my complex fraction here. So, multiplying y plus 3 over y times y minus 1, the y's will cancel out, and that'll leave me with y plus 3 times y minus 1, minus multiplying 4 over y minus 1 times y minus 1, the y minus 1's will cancel out, and that'll leave me with 4y. In the denominator, multiplying y over y minus 1 times y minus 1, the y minus 1s will cancel out. So that leaves me with y times y, which is y squared, plus multiplying 1 over y times y minus 1, the y's will cancel out to leave me with y minus 1. All right. From here, ladies and gentlemen, I'll go ahead and distribute the numerator. So distributing the numerator, I'll end up with y squared minus y plus 3y minus 3 minus 4y. In the denominator, I still have the y squared plus y minus 1, just like so. The next thing to do is to combine your like terms in the numerator. So I'll have y squared, and then a negative y plus 3y is a positive 2y, and 2y minus 4y leaves me with negative 2y. And this is going to be minus 3. All of this is going to be over y squared plus y minus 1. Notice, ladies and gentlemen, that your denominator is not factorable. So even though we could factor the numerator, it's not going to cancel out with anything. So that means that your answer is as follows. It's y squared minus 2y minus 3 all over y squared plus y minus 1. And that's the answer to problem number 8. All right. In problem number 9, we have 3 to the negative first power plus 2 to the negative first power all over 4 to the negative first power plus 6 to the negative second power. Please realize that in its current form, this does not appear to be a complex fraction. However, because we have these negative exponents, we can very well rewrite the problem into 1/3 plus 1/2 all over 1/4 plus 1 over 6 squared. All right. Going a step further, we'll have 1/3 plus 1/2 over 1/4 plus 1 over 36. Okay, so what we want to do now, ladies and gentlemen, is multiply everything by its common denominator, and that's going to be 36. The first number that 3, 2, 4, and 36 have in common is 36. So I'll be multiplying each and every element by 36. So let's see how that works out. So multiplying 1/3 by 36, 3 goes into 36 12 times, and 12 times 1 is 12. In other words, 1/3 of 36 is 12. Plus, half of 36 is 18, or you could very well say that 2 goes into 36 18 times, and 18 times 1 is 18. 4 goes into 36 9 times, 9 times 1 is 9. And 36 goes into itself, so 1 times 1 is 1. We now end up with the following. 12 plus 18 gives you 30 over 10, and this answer here simplifies to 3. So that's problem number 9, ladies and gentlemen. The answer is 3. All right, that's problem number 9. Moving on to problem number 10. In problem number 10, we have m to the negative 2 power minus n to the negative 2 power all over m to the negative first power plus n to the negative first power. Like our previous problem, I'm going to rewrite the original problem to expose our complex fractions to get rid of those negative exponents as well. We'll end up with 1 over m squared minus 1 over n squared all over 1 over m plus 1 over n. We'll be multiplying each and every element by the common denominator of m squared n squared. All right, so because we have those multiple terms in the numerator and the denominator, we'll be multiplying by the common denominator of all of the denominators in our original problem here. So 1 over m squared times m squared n squared, the m squareds will cancel out to leave me with n squared, minus multiplying 1 over n squared times m squared n squared, the n squareds cancel out to leave me with m squared. All of this is going to be over. Here, multiplying 1 over m times m squared n squared will leave me with m n squared, plus multiplying 1 over n times m squared n squared will leave me with m squared n. Now what we will do, ladies and gentlemen, to see if we can simplify this any further, so what we'll do next is we'll go ahead and factor the numerator and the denominator to see if we can simplify any further. Your numerator is a difference of 2 squares, and you'll end up with n plus m times n minus m. In the denominator, we can factor out m n. What that'll leave for us is n plus m. Notice that we have a common factor in the numerator and in the denominator. So I can cancel out that n plus m, and that'll leave me with n minus m all over mn, and that's going to be the result of problem number 10, ladies and gentlemen. That was a good problem. Let's go ahead and check out our next problem. Problem number 11. All right. In problem number 11, ladies and gentlemen, once again, notice that you have these negative exponents, but be careful with them because you need to make sure that you're rewriting these complex fractions correctly. So we'll end up with 1 over x squared minus 2 over y. Notice that my exponent on 2 was to the first power, so I didn't need to move that into the denominator. Only the variable y had a negative exponent on it in that second term in the numerator. In the denominator, I'll have y minus 2x squared. So next, in order to get rid of these complex fractions here, I'll be multiplying by the common denominator of x squared y. All right, so that'll be multiplied to each and every term. So let's see what happens here. I'm going to distribute this to the numerator here, as well as both terms in the denominator. All right, so notice I got my arrows popping. You got it. So what happens in the numerator is the x squareds will cancel out to leave me with just y. Minus multiplying 2 over y times x squared y, the y's will cancel out to leave me with 2x squared. And now in the denominator, I have y times x squared y. That gives me x squared y squared minus 2x squared times x squared y gives me 2x to the 4th power y. So if we factor what we can see if we can cancel something out. Let's see what happens. In the numerator, we'll just bring over our y minus 2x squared, and in the denominator, we'll be able to factor out an x squared y. So factoring out x squared y, that leaves me with y minus 2x squared. And so now, ladies and gentlemen, what we'll have is the numerator and the denominator canceling out. Remember, things cancel to just 1 when you're dealing with factors. So y minus 2x squared goes into itself once in the numerator, and it goes into itself once in the denominator to leave me with a result of 1 over x squared y, which is my answer here for problem number 11. All right, ladies and gentlemen, that's going to do it for us for problem number 11 and for this lesson on complex fractions. As always, please rate, comment, and subscribe. And if you're able, ladies and gentlemen, please donate to bring more free videos your way. Peace.
Oh Lord, there's so many kind of fractions. They got proper, improper, addings, subtracting, multiplying, dividing, mixed numbers, LCD, ooh, that's like my TV, simplifying, and my favorite of all, your least common denominator.